Yes!
In our last lesson, we talked about how arc length is a fraction of the circumference of a circle. Today we're going to add in a similar concept, but it has to do with area. So first, our formula for the area of a circle is pi r squared. If you mix these two formulas up, just think about the fact that in area the units are squared, and for the area of a circle it has a squared in the formula. So when we talk about sector area, just like arc length was a fraction of the circumference, sector area is a fraction of the whole area of the circle. So a sector of a circle looks something like this. So if we talked about the arc length being the crust of the circle, if we're talking about pizza, the sector area would be like a slice or slices of pizza. So this right here would be a sector. And just like our arc length, it could be a small slice like this, or it could take up most of the circle. This would still be considered a sector as well. It's just a piece of the area. So as we go through a few examples here and kind of discover the formula for sector area, you should notice some similarities between how we find sector area and how we found arc length. So let's say that this circle, it has an area of 4 pi inches squared. If we were trying to find just the area of this sector, so it's half of the circle, then I would need to take half of the total area. So I'd say 1/2 times my 4 pi, which is 2 pi inches squared. We'll just keep things in terms of pi. So this piece would be 2 pi inches squared. So same size of circle, same area. But now I'm looking at 1/4 of the area. So I would need to take 1/4 of the total area. So 1/4 of 4 pi is just pi inches squared. So then moving to a central angle measure that is not as normal for us. So 57 degrees for a central angle, trying to find the area of this sector. Now we get to that point where we're trying to figure out what fraction is this of the entire circle, and we've got to go back to that 57 degrees out of the total 360 for all of the central angles, and this is the fraction of the circle that we're looking for. So we've got 57 over 360 times 4 pi. So we'll get about 0.6 pi inches squared. But you knew it was going to be smaller than 1 pi because that was the quarter of a circle was 1 pi. So it's okay that it's 0.6 pi. So hopefully what we're noticing is that we're still taking a fraction of the whole circle, just instead of using circumference this time, we're using area, since we're talking about sector area. But that fraction still comes from the same place. We're looking at that central angle over 360. This first one could have been that 180 degrees over 360 is 1/2. This one could have been 90 over 360 is 1/4. So really a very similar concept to what we were doing with arc length. So our formula for sector area, we're going to write it like we did arc length, that angle over 360. But instead of taking a fraction of the circumference, we want to take a fraction of the area. So where our first step for finding arc length was always finding the circumference first, now we're going to find the area first so that we can take the fraction of it that we want. Okay, let's look at some examples. So for all of these, we're going to find the area of the shaded sector, and we are going to leave our answer in terms of pi, but remember that if you're wanting to go from in terms of pi to rounded to the nearest tenth, something like that, all you would need to do is multiply by pi and then round. So for example 1, we're looking at this sector that has a central angle of 120 degrees. So just like with our arc length, before we jump into using the formula for sector area, I'm going to go ahead and find the area of the whole circle. So for the area of the whole circle, my radius here is 5, so I'm using that pi r squared. And I get that my whole area is this 25 pi inches squared. Okay, so now that makes finding the sector area that much easier because I'm just going to take my fraction 120 out of the whole circle, and then I'm multiplying by 25 pi. You should get about 8.3 pi inches squared. If you're wondering how to round the number that's in front of pi, because even though we're keeping it in terms of pi, we're still going to end up with some decimals sometimes. And just in general, if we're keeping things in terms of pi, usually we go to one decimal place or to the nearest whole number. So that's a good rule of thumb. If it doesn't tell you to go to the nearest tenth out in front of that pi. So for example 2, we have a much larger sector that we're looking at, but still going to start with the area, and this time we're given the diameter. Anytime, if you're looking like in your textbook, anytime they give you the drawn in diameter, that number next to it is the diameter. If they're wanting to give you the radius, they'll put it next to a radius. So for our area, still using pi r squared, but I would just have to think through that if the diameter is 8, then the radius is 4. So my area is the 16 pi centimeters squared. So now, if I'm finding the area of this whole sector, I do need to figure out this central angle. Okay, so if I know that this little piece is 30 degrees, then I can take 360 and subtract 30 to get the central angle that I need. So I'll get 330 degrees. So that tells me I need 330 out of 360 of that total area times 16 pi. And you should get about 14.7 pi centimeters squared. If you're not getting these, make sure that you're putting this in your calculator correctly. We've talked about this before, so with that 330 over 360, make sure you've got it in parentheses. You can use division if your calculator doesn't have that fraction feature, and then multiplying by 16. That's getting you that 14.7. I do want you to try example 3 on your own. Remember, start with finding the total area, and then you are going to have to figure out the central angle before you can find the sector area. But go ahead and pause the video and give it a go. So you should have gotten 1 pi feet squared. Make sure that for your total area that you use the radius, so the radius should have been 3, and then squaring it would get you the 9 pi for the whole area. For finding that missing central angle, remember that a semicircle is 180 degrees, or just looking at these angles, that they are a linear pair, they're supplementary, so they add up to be 180. So taking 180 minus 140 gets us our missing angle of 40. So 40 out of 360 times 9 pi is our pi feet squared. All right, our last example, example 4, I do want you to go and try this one on your own as well. So Rocket here proved that you can do this on your own. I apologize for the M. I do not know what happened here. When I highlighted it, it like bled. It looks like the logo on a Monster can. I don't know. So the area of this sector should end up being 108 pi meters squared. Make sure for your area that 12 was the radius this time. Squaring it, we get 144 pi meters squared for the whole area. And then the highlighted region here, since that's 90 degrees, we could subtract from 360 to get 270 degrees for this angle. So we can take 270 over 360, or we could notice that it's 3/4 of the circle, and that would work as well. And multiplying by our total area should get you that 108 pi. All right, so that's it for today. I hope you thoroughly enjoyed sector area.
Well, I know that you're a boy. I know you're not a girl, but it's a bit that we're doing. You're Jessica Day in this one. Okay. Do you have any polka dots that you could wear?